So here is the next example. I will read it. It says a beam of parallel rays spreads out after passing a thin diverging lens. So it spreads out, therefore they emphasize it's diverging. As if all the rays are coming from a point that's 20 centimeters from the center of the lens. Okay, so here is what they're saying. Here's a diverging lens. So this is the next example. We have a lens. Here's the axis of the lens. Here's F. Here's F. And if we send parallel rays, so here's an array that is parallel, it will go this way. And if I send another one that is parallel, it will go that way. So it appears as if all of them are coming from this point. Okay, they're coming from this point. And they tell us how far that point is. They say it's 20 centimeters, I think. Let me read it again. Yeah, 20 centimeters. It says here, you want to use this lens to form an image that's upright but 1/3 the size of the object. So where would you place an object so that the magnification will equal to positive 1/3. Okay. Where would we place our object in order to get a magnification that is positive 1/3? I'm going to ask you the first question. What's the focal length?
20 centimeters.
20 centimeters. Almost. Why do you say almost?
Is it to the surface of the lens?
No, it is 20, but
Oh, negative?
yeah, it's a diverging. So that's all. Okay. They didn't tell us explicitly, but they said it's diverging. We're supposed to fill it. Okay. So here's what we have. Magnification is equal to minus S prime over S, right? And we would like it to be how much? 1/3. Therefore, S prime is equal to minus S over 3. You agree? Yeah. Minus S over 3. And now we're going to use our lens equation. Okay, we're going to use our lens equation. Yeah, I think my algebra is good. So 1 over S prime plus 1 over S is equal to 1 over F. What's 1 over S prime? It's 3 over S, but negative, right? So I would have here minus 3 over S, right? Because the inverse of that. Plus 1 over S is equal to 1 over what? Minus 20, right? 20. So I'll put here 20. So everything is in centimeters, so the answer will be in centimeters. 1 minus 3 is minus 2, so I have minus 2 over S is equal to minus 1 over 20. That means you can just cross multiply. So S will be 40. That's where you would place your object. So I have a question for you. So we solved this, right? So earlier with a converging lens or convex lens, we were able to produce images that were real, right? And virtual. The image would be real if the object distance is greater than f. The image would be virtual if the object distance is less than f. Would the same thing happen with a diverging lens, or a diverging lens can never produce a real image? It's just a single diverging lens. And I claim that it's always a virtual image, and it will always be reduced. But we need to prove that, right? So I'm going to show you that a diverging lens will always give you a virtual image. Just, we're using single lens here. So how do we prove that? Well, it becomes a math problem, and you just have to follow it. You need to remember that for a diverging lens, f is equal to minus the absolute value of f, right? Because what's the absolute value of f? That's going to be a positive number. Minus the absolute value is guaranteed to be negative, right? So f is negative. That's what I'm trying to say, okay? So we get this. I'm going to actually just directly use this equation here. Because 1 over s plus 1 over s prime equals to 1 over f. So s prime will equal to this, right? Equal to that. So here is, let's write that down. So I get s prime equal to s times f over s minus f. And that's equal to s times negative the absolute value of f over s minus the absolute value of f. Okay? So I get s times f over s minus f, that's s plus f, plus the absolute value of f. This fraction here is positive or, I'm sorry, this is minus. So the numerator is negative. The denominator is positive. So this is always less than 0. So the image distance is always less than 0, so it's virtual. So the image is always virtual. Okay. Next thing is the magnification. Okay, so that's the 0, so the image is always virtual for a diverging lens. But the magnification, which is minus s prime over s, will equal to. Here is s prime. If I do minus s prime, what does it become? This minus sign goes away. And then I divide by s. What do I get? I will just get this, right? Just minus s prime over s. So the minus sign goes away, and you're divided by s, so this goes away. So you just have this. The absolute value of f over s plus f. Is this positive? Yes, it is, right? It's positive. So the magnification is always positive, so that means it's upright. Is it larger or smaller? Is this more than 1 or less than 1?
Less than 1.
It's less than 1. You have a number divided by that same number plus something, and that something is positive. So it would be, this is, so that means this. The magnification is more than 0, but it's less than 1, okay? All right. We can, yes, Nick, you have a... Okay. Do you have a question? Martin? No? Feel free to ask. I'm not in a hurry.
No, I don't.
No, okay. Okay. Yeah, I mean, those minus signs can be kind of annoying, right? Now, you can combine lenses. So far, what I've talked about it's just a single lens. What if I have two lenses? One and then another. What happens?
Where's the second lens?
Okay, yeah. So, and I ask, you have an object standing in front of this lens, and then there is another lens. So the key idea, and then you're asked, where is the final image? Where would the image form? And then what is it? Upright, virtual?
Does it matter if it's past the focal point, like the second one?
So those are the details, right? Yeah, those are the details that we need to know to solve the problem. But the basic idea is this. The object, the first lens will form an image, and that image will be the object of the second lens. The image formed by the first lens is the object for the second lens. That's the idea.
Well, like the second lens itself, if it's like before the focal point.
It does not matter.
Okay.
Yeah. So what you do is this. Imagine I remove that lens. There is an image. Now that image I place in front of it this other lens. Now there is an image of that image. That's where the final one. So that's the key idea. Okay. There is an example here. You combine lenses, especially when you combine two converging lenses. A single converging lens can give you a magnifier. For example, here's a magnifier. Let's say I'm looking here. This is a tiny object. If I remove the lens, maybe it's a little end. I can't really see it with my eye. I can only bring it so close, and then my eye can't focus anymore because our eyes, we have a near point, right? So, so what I do is I place a lens here, and then looking through the lens, I see a virtual image here, and I see it magnified. So I can magnify that thing, and that's how magnifying glass works. It's one converging lens. I can also combine two lenses together, and that's where you can magnify what's already magnified, and you get what's called a compound microscope. This is technically a microscope by itself. You're trying to view, right? View something and make it larger. You combine two, you get what's the microscope. That's the simplest microscope. Of course, if you try to do just two lenses at home, you will get horrible images because you have all kinds of corrections that you have to do because there are imperfections and so on. Or you can get a telescope also. That's also two lenses. They are both convex. They're both converging lenses. And it just depends how you put them. The idea for a microscope, you're trying to view some object that's close by, but tiny. The idea for a telescope, you're trying far away, but it's huge. Like the moon or the sun. No, not the sun. Something else. Yeah. Some object that's far away and big. Yeah. So let's look at the first one here, this combination of lenses. It says we have two converging lenses, A and B, and they have focal lengths 8 and 6 centimeters. This is when the projector would be a nice thing to just display the problem. I'm gonna try my best to draw it. Let me pause this so it doesn't keep recording me drawing. Okay. So again, the two lenses are 36 centimeters apart. Lens 1, this is the focal point on this side, this is the focal point on the other side for lens A. And both are 8 centimeters, so 8 centimeters, 8 centimeters. And then for lens B, how far is this? 6, right? And we're going to place an object. And our object is going to stand right here. It's going to be 12 centimeters away. So if this is A, 12 centimeters is going to be somewhere here. This is our object. This is Y. And our object's height, let me write it down here. Y is going to be 8. They like the number 8. 8 centimeters high. Yeah, 8 centimeters high. Right. And I'm going to say the object distance from here to here is what? From here to here is 12, right? We said from here to here is 12, right? They're telling us that. 12 centimeters. And our goal is to find the image, the final position of the image, and then how big is it and whether it's magnified or not. I mean, the magnification. Okay? So we will use this first lens to find the image. Okay? I'm going to call it, the image would be S prime, right? So we say S prime is equal to S times F, right? Over S minus F. Do we agree? And which F?
The first one.
The first one, which is 1, right? Let me call it F1, F1 here, F1 here. So S is 12. F1 is 8. Yes, 8. And then 12 minus 8. That gives me, this becomes 4. 8 over 4 is 2. 12 times 2 is 24 centimeters. It's positive 24, right? So the magnification here, M1, magnification due to lens 1 will be minus S prime over S. Yes? S prime over S. So we get minus 24 over minus 24 over what is S? 12. 12. So I get minus 2. Okay? So the image is gonna be here. We said S prime will be 12, will be 24. Where is 24 at? This is 36, right? This is 8. I mean, it's not to scale. If this is 8 and this is 6, that's 14. 8, so 24 will be where? Will be somewhere here, right? Where is that somewhere? Let's see. It's gonna be somewhere here. If this is 24, what would this be? What would this distance be? 12, or
18.
24, 12,
12,
isn't it?
Yeah.
I will double check my work.
It is 12.
It is 12, all right.
36 minus
Yeah, this is 24. Yeah, this is 24, so this is 12, okay? Okay. So that's our object now. That's the object for this lens, okay? So where would we will need to do this process again. So now I would say, let me see the notation they use. Yeah, they say S image 1. Yeah.
S1 prime?
Let me call it SB. Yeah, I should have called it SB. So let me write it. SB is meaning the object distance from lens B is 12. Okay, how about that? Yeah, that's a good one. 12 centimeters. So therefore SB prime, right, will be this. It will be SB times F2. No, not 2. F1 prime, right? It should have been FB also. That's a bad notation that I put. But you know what I mean, right? F1 prime, which is 6 centimeters, over SB minus F1 prime. SB is 12. 6 over 12 minus 6. That seems like a 12. Okay, 12 centimeters. Okay. Therefore, the magnification, let me call it M2 now, magnification from this other one will be minus SB prime over SB. And that will give me minus 12 over 12, which is minus 1, right? Okay, minus 1. Let me just It seems correct. What's the total magnification? Let's say the first one made the image double, and the third one made that double another double. What's the total? It will be 4, yeah, quadruple. So you multiply the two magnifications.
Which is 2.
So the total magnification, yeah, the total magnification will be M1 times M2, and that's minus 2 times minus 1, and that is positive 2. Okay, positive 2. Now, where would the final position of the image be? Well, we said it would be at 12, right? 12 where? Where is 12? Yeah, so it would be 12 centimeters this way. So it's going to be here. That's so the image, the final image is going to be here, and it's going to be upright, right? It's going to be upright, but twice the size. This is why, let me call it double prime. That's the final image height. Okay, so the final position of the image is here, and that's 12 centimeters. So it will be 12 centimeters to the right of the second lens. Yeah, 12 to the right. And what would be the height of the image? H double prime? No, Y double prime?
16 centimeters?
Yeah, this was 8. No, this was 8. So that one would just be double it, so it would be 16 centimeters. Okay. That's the. Well, now it's time to go through some problems from the worksheet. So I'm going to pause here, and then I'll give you got the worksheet earlier, right? Let me just pause here.